Welcome back to another lecture of differentiation. Now, in today's lecture, we are going to discuss about the method of substitution. Now, let us start with the topic. Now, what is called substitution? Substitution means replacing the variable x with suitable values. Now, what kind of values? Now, for that, let us take an example over here. Now, we already know that the differentiation dx of sine inverse x by a, we already know the differentiation of sine inverse x by a. Or let us take an example, differentiation of sine inverse x. Let us consider this only. So in this particular case, we already know the formula. This is 1 by root over of 1 minus x square. So we pretty much know the formula of differentiation of sine inverse x. That is 1 by root over of 1 minus x square. But what will happen if we are given the differentiation, that is dx of sine inverse root over of a square minus x square, like this? What will happen if we have been given the differentiation of this one? So in this type of questions, we generally use chain rule. Now what does the chain rule suggest? The chain rule suggests that at the beginning we will differentiate the sine inverse part, and then we are going to differentiate the root containing term. And after differentiating the root containing term, we will differentiate the values or the variables present inside the root. So we generally follow a chain rule over here. But this will take a lot of time and this will be a bit lengthy. So what I am going to suggest is to use few standard substitution to reduce the length of the sums, or to reduce the length of the solution part. Now what are the standard substitution that we are going to discuss? Let us start with that one. Now let us discuss what are the different type of substitution that we are going to use. Now remember that these substitutions are standard substitution that we can use in maximum number of cases, but in few of the cases you might see a different substitution. You need to think about that and then you need to solve. It depends on the question itself. So let us start understanding what is there in the substitution part. Now in this particular case, let us start with the first one. Whenever we are getting this type of question, a square minus x square. Now in this type of substitution, either we can substitute a sin t or we can substitute a cos t. Now many of the students generally have a doubt that which one to substitute, whether we need to substitute a sin t or whether we need to substitute a cos t. Now this substitution entirely depends on the question itself. Sometimes we need to substitute a sin t and sometimes a cos t. It depends on the question. Similarly, if we are getting a square plus x square, then either we will substitute a tan t or a cot t. Then if we are getting x square minus a square, then we are going to substitute a sec t and or a cosec t. Similarly, if we are getting a minus x by a plus x or a plus x by a minus x, then in this type of question, either we are going to substitute x as a cos 2t. In some of the substitution you might see we have substituted, instead of a cos 2t, we will substitute a cos t in that case. And in the last one, a cos x plus minus b sin x, we are going to substitute the value of a as r cos alpha and the value of b as r sin alpha. Now these are the standard substitutions that we have already discussed. Let's take example and see how we are going to substitute and how we are going to simplify that. Now let us understand this example. The question specifies that we are getting sine inverse 2x by 1 plus x square. We need to differentiate this sine inverse 2x by 1 plus x square. Now if we are going to differentiate this one directly, then what will happen? First we are going to differentiate sine inverse, then we are going to differentiate the part that is present inside this sine inverse. That means first we need to differentiate sine inverse, then we are going to differentiate 2x by 1 plus x square. But the problem is, as soon as we start with this part, the problem arises. What is the problem that we are going to face? We can see that there is a variable in the numerator as well as there is a variable in the denominator. So this will become u by v method. So after doing differentiation of this one, then again we are going to differentiate this part in the form of u by v. So it will be a very long process. So how can we reduce the length of the solution in this particular type? See, in this one we will consider the value of x as tan t. Now when we were discussing about the substitution, we discussed that whenever we are getting a square plus x square, we are going to substitute this part x as a tan t or a cot t. Now a in this particular case is 1. As you can see over here, we are getting 1 square plus x square. So a in this particular case is 1. Now since a is 1, we are going to substitute 1 tan t, that is basically tan t. Now let us substitute. So this part will become sine inverse, or let me only solve this part. So this is 2 tan t by 1 plus tan square t. Now this one can also be written as 2 sin t by cos t, and this part can be written as 1 plus sin square t by cos square t. So if you simplify the denominator part, keeping the numerator as it is, so we are getting cos square t plus sin square t by cos square t. This cos t and this cos t will cancel out each other. We are getting cos t after cancelling. Now this cos square t plus sin square t, it is an identity, and the value of this identity is 1. So basically we are going to just revert this part. We are solving this like this one, 2 sin t cos t, and this one we already know this is sin 2 t. So our question, that is sin inverse of this one, became sin inverse of sin 2 t. Now in the inverse trigonometrical function, there is a concept that whenever we are getting sin inverse of sin 2t, this inverse and this trigonometric function will cancel out each other, and we are getting 2t over here. Now the only problem is the starting question is present in the form of x, and the final answer is coming in the form of t. So for that part, we are going to discuss about this part. In this one, if we take tan on the other side, it becomes tan inverse x is equals to t. So we are getting the value of t from here, and we are getting this as tan inverse x. So basically we are getting 2 tan inverse x as the question. This is the question that we are getting from this one. So if you are going to differentiate this part, so instead of differentiating this, we will differentiate this one. I hope you understood how we are going to substitute and how is the process happening. Now let me solve the last part, that means let me simplify the differentiation part. Now we already got the value of sin inverse 2x by 1 plus x square in the form of tan. We got this as 2 tan inverse x. Now if we are going to differentiate sin inverse 2x by 1 plus x square, instead of differentiating this, we will differentiate ddx of 2 tan inverse x. We are going to differentiate this part. Now 2 is a constant, will go outside the differentiation, so we are getting d dx of tan inverse x. Now in the previous lectures, we have already discussed the differentiation of tan inverse x, and the differentiation of tan inverse x is 1 by 1 plus x square. So the value that we are getting is 2 by 1 plus x square. This is your answer. I hope you understood the substitution in this one. In the next lecture, we are going to discuss few more examples based on this concept.